Hi, today we're gonna see how to save and load the models. Okay, so these are the basic code. Here I'm importing all the necessary libraries. I'm making an environment. I'm importing an environment. Then I'm vectorizing it. So through dummy vector environment. Then I'm loading the algorithm and policy. I'm okay. So till this, let me execute the code. Okay, the model has been learned. Now we're gonna save the model. So how to save the model? First time this particular code is to create a directory to the particular location. Now I'm defining the model with particular algorithm and this policy, this environment. It's gonna learn at 10 steps. To make it quick, I just made it to 10 steps. So model.save, it will gonna save at this particular location. Okay, it's gonna save as a zip file. So what actually it is doing is, from this environment which has been learned, I'm taking a sample observation value and model is predicting the what is the action it should be done. Okay, so this is a particular value. Now I'm loading the this model whatever has been learned in the 10 steps. Now to load the model, just algorithm name dot load the location. So the model has been loaded. Again it's going for the prediction for the same observation value. What should be the output? The values are same. Okay, the model has been saved and loaded again. Okay, how to save the model with parameters? This particular algorithm A to C, it's having four extra algorithms. Four extra parameters: n steps, gamma, and verbose. I saved into this particular location. So with this particular parameters, the model has been saved. It will be saved as a zip file. So now I'm loading. Okay. While loading, you can override the parameters. So here verbose is 0, right? The same algorithm name dot load. Here I'm overriding with 1. Okay, so from the 0 I'm changing into 1. When you load, see, the value has been changed to 1. Okay, this is how you have to save and load the model. Now we'll check what is wrappers. So wrappers are the functions which wraps the whole environment. Okay, there are some three basic wrappers. Even you can create your own wrappers. Just check the documentation from the baseline. Here we're gonna see about some basic one. Vec normalize. So what are the observation value from the environment? Using this vec dot normalize, the observation value will be normalized. Okay, so execute this line. So this is the environment where I have to normalize the observation value, store into the same environment, execute it. So see, the value has been normalized between like, I don't know exact value. So it will be normalized. The values will not go from negative to like negative -2 to +2. Sometimes the value ranges, so all those values will be normalized. Okay, next we'll see about recording. So with video recorder, whatever the rendering is happening, we can record it for a particular length. Okay, so first I'm declaring what is the location the video should be loaded. So while wrapping, whatever the environment is wrapped, again it showed into the same variable. Okay, so here env is our environment which has been imported from the gym. I'm wrapping it, again I'm storing in the same environment. Okay, so this is the code which I'm importing the particular environment, particular wrapper. Let me explain you what are the parameters. So first thing is, what is the environment which we gonna play with? Video folder, record video trigger. Okay, this is the thing where it triggers the function to record. It needed a function as input. You can't just pass some int or a range function, it should be a particular function. Just use this function, it will just record from the 0 to the video length. Okay, then the video length, the name of the prefix. So execute this code. So here I declare the model and policy and the environment the same as the env. So it's gonna learn, and we have to close the environment. Okay, so whenever it's giving recording or rendering, you have to always close the environment, otherwise it will be stuck on the loop. You will get an error, then you have to restart the terminal. Okay, so let us okay, after model is done, so you can check the rendered model. Okay, there's one more wrapper, check nan. So wrap this into an environment, and while learning it will check whether if there is a nan or infinity value in your vectorized environment. If it is there, it will raise an alert. That's it. So this is the end of wrappers. Okay, thank you.